Hello guys, I completed my previous post stating I will follow up with more hands-on posts, and here I am. Today we're going to see how to use Nmap to gather reconnaissance on a target machine. More exactly, here we're talking about active reconnaissance. First of all, reconnaissance is gathering information about the target system. You can gather information in two ways. With passive reconnaissance, you don't interact with your target, so you simply gather information through public domain sources like search engines and domain registrars, but without interacting with the target. As to search engines, we can talk about passive reconnaissance only if you don't click any of the links you find. Because when you click, for example, the website of the company you found, or you perform any other active techniques like the port scanning we're doing right now, you get into active reconnaissance, which means you interact with the target. In this case, so we're talking about active reconnaissance. We're going to be using Nmap to see what kind of ports are open on the target machine and what services are running. In a later post, I'm going to use this information to attack the victim machine. By the way, this is the difference between vulnerability assessment and penetration testing, or pen testing, or pen test, the way you want to call it. A vulnerability assessment simply tries to understand what kind of vulnerability potentially exists on a target machine, but it doesn't exploit them. A penetration testing instead launches specific attacks trying to use these vulnerabilities and see if the target machine is successfully attacked, and if so, it provides suggestions to the customers in order to harden the operating system accordingly. Alright, that's boring stuff. Now, let's calm down to get our hands dirty. Okay. Before doing all this, we need to do some network configurations here. I'm using two different virtual machines. This is the attacking machine or analysis machine, the way you want to call it, which is Kali Linux version 1 2017. This is the victim machine, which is a deliberately vulnerable virtual machine called Metasploitable. And I need to follow a specific configuration for this virtual machine because you can't expose that to the internet directly. It will be hacked in a matter of seconds and could lead to your system being compromised. So I need to configure it as an internal network, but I need at the same time to be able to access the Metasploitable virtual machine from Kali Linux. So for this purpose, I have two network adapters on my Linux virtual machine. One is configured as net, and the second one is configured with a custom network. I created this custom network adapter. Okay, we're gonna change this IP address right now because it's wrong, and we're going to do that both on Kali and on Metasploitable, so the two machines can communicate. Anyway, we can do that from command line Now let's check back our network configuration, and this time we have the right IP address. Now we're going to do the same for Metasploitable. The only difference is here I will need to use sudo because this is not the root user. And the difference is that here I'm using 8th1 because this is the second network adapter on Kali. On Metasploitable we have one only network adapter, which is a custom network configuration, because we don't want that configuration to be accessible from the internet. Of course, we assign Metasploitable an IP address which is on the same subnet as the custom network that is on Kali virtual machine, so the two machines can communicate. I had made a mistake, sorry. There was a missing space. Now, if we check our configuration with ifconfig, we'll notice that we have the right IP address. Okay. That being done, we should be able to ping the vulnerable virtual machine from the Kali Linux virtual machine. No, sorry. That's the wrong virtual machine, and we should be able to do the same anyway from Metasploitable, but let's start from pinging the Metasploitable virtual machine starting from Kali. Sorry, I mistyped the IP address. And there you go. The two machines communicate, like you see. Now let's do the same and let's ping the Kali Linux virtual machine from Metasploitable. And we should be able to communicate. In fact, perfect. That's just what we wanted. Okay, now we created all the necessary conditions for us to go through and perform our network scan. So let's start talking about Nmap and the way it works. Now, for all concerned in my explanations and all I need to leave out for time concerns, I will refer to the official guide that can be found at this website, nmap.org, which is the official site for Nmap. Here you can find all the explanations you want, and for anything I can't be more detailed, I will refer back to this website. Anyway, it's important to understand, first of all, the different status messages you can find when you perform an Nmap scan, which you can find here. And I warmly recommend you to check this page before starting working with Nmap. Alright, now let's start seeing how to perform an Nmap scan. I'm not here to do some chitter chatter, I'm here to work. So, first of all, how to perform an Nmap scan. The most basic scan you can perform is the following: Nmap followed by the IP address of the target machine you want to check. So here you go. So let's start out with this specific scan. Alright, you'll see that a bunch of open ports are returned with several services running, and you see that all these ports are open. In fact, this is a very vulnerable system. Now you understand why I can't expose that to the internet. Several of these services being open form a real vulnerability, especially FTP and Telnet, because they're not encrypted. So I can easily exploit any system going through these two services, just for starters. As a matter of fact, Metasploitable is an example of how not to configure an operating system. It's just like a sort of baseline for you to harden an operating system and build an operating system according to best practices. And it's an easy way for you to perform basic hacking without getting into troubles, because remember that port scanning a system where you don't have any authorization to do so might cause you legal troubles according to the regulations of the specific country you reside. So in the US, that can really mean asking for troubles. So that's how you can play safe, by using this type of system here. Anyway, you'll notice that it looked like the software got pretty much stuck, as if it was doing nothing, but that's because of the way Unix Linux applications are implemented. Unlike Windows, they're not very chatty, so they don't give you feedback about what you're doing. But if this throws you off because you're more used to Windows, you can add another option that makes the output a little more verbose, which is -v. So if I add a -v to the previous scan, you'll see that I have more feedback messages. That might be or not useful according to your likings. I'm more of a Unix Linux guy. Okay, we can do much more than that with a map. A map has a bunch of options, and here we see only some of them for time constraints that allow you to do much more than that, and you can gain knowledge about what operating system is running on the target machine, for example, which is called operating system fingerprinting. And there are several scanning techniques. So we're going to start examining two of the most common ones. The most important one, and which is pretty much the standard, is the Tcp Connect Scan, which goes practically all the way through the three-way handshake connection process. If you don't know what the handshake connection is, this is described here, and it's the way two computers communicate between each other. It's pretty much given for granted if you came to this point, I mean. If not, I recommend you a basic networking class. It's not my business to explain what this means, I mean, right now, but that's the way a TCP Connect Scan works, and it's performed this way. Remember, you can always set the -v if you want a more verbose output. Okay, so this goes all the way down the three-way handshake process, so it gives the target system more information about your system because there's a full communication going through the two computers. You might want to be a little stealthier, and so you might want to use a different type of scan called Tcp Scan, or also known as stealth scan, which is exactly this one, SS. It's called stealth because instead of going all the way through the three-way handshake process like here, when you got an ACK here, the client doesn't send a SYN ACK to the destination computer, but it resets the connection. With the results that we have a half open connection. So you won't have this and the communication doesn't complete. As a matter of fact, this is a way for you to launch denial of service attacks, because if you keep adding half open connections, that could cause the server to fill its buffer and it would cause a buffer overflow, but it's a form of attack that can be prevented pretty easily. Anyway, the way you launch a stealth scan is by using the SS option. That's normally what I like to use. It's a little slower than Connect Scan, but it's a little stealthier, like the name suggests. Now, all these differences doesn't tell you a lot. Now, the way we performed the Nmap scan so far doesn't allow us to understand very clearly the difference between these different techniques. In fact, it looks like they all return the same results, the same ports, and the same services. So you would think, why bother studying different scanning techniques? First of all, they return a huge number of ports, but that's the way the system is implemented. Like I said, it's a test system. A real world target will give you different results than this. And first of all, it can be much more beneficial to us in order to understand the difference between these scans to see how they look like on the wire. And that's why I'm going to use Wireshark to capture traffic, and I'm going to show you the different Tcp flags used when performing the different scans, which can be much clearer than seeing the scan output only, without any further explanation. So let's start by doing again a TCP Connect Scan. Now I'm going to start capturing traffic here on this interface. That's the one I use to communicate with the Metasploitable machine. Now I need to put the network card here in promiscuous mode, and that's why I need to authenticate. You'll see that the packets were captured here. Now we stop the capture, and we're going to see what kind of TCP flags we find. You see that we have a SYN ACK. So we see the type of flags we would expect to find in a normal three-way handshake, which means the communication between the two clients have been correctly established. Okay, now we're going to perform a stealth scan again. I'm going to start a packet capture again. I'm not interested in saving my previous scan, so I'm going to start over. Now Wireshark is waiting for input on my end, and there you go. Let's have a look at the TCP flags. We have a sync connection, but we don't have a SYNAC. At a certain point the connection was reset. You see here we got a reset. In fact, if we follow the TCP stream, instead of completing the three-way handshake, our client reset the connection. That's the way it works. Okay, I'm gonna keep Wireshark open because it's gonna come in handy later on. Now, another thing I want to point out is that by default, Nmap scans only the most common ports, the so-called well-known ports. But that's not what you want to do in an actual pen test, because there could be services configured on a non-standard port with the so-called security through obscurity, or services using dynamic ports which are not exactly mapped, and they don't fall into the well-known ports range. So you can have Nmap to scan all ports on a target machine, and we can do it sorry, I have some problems with the caps lock key sometimes. I need to go through this. Alright, so if we add this option, we're going to scan all ports on the target machine. Now, I'm not gonna capture the traffic with Wireshark because this is the same type of scan we performed before, only with more ports involved. And you see that some dynamic ports are shown, so we don't know what they are, but there are some services using those ports, probably some web connections or some other services running behind the firewall on the local computer there on the Metasploitable machine. Alright, so that can give us more information. Another type of scan we can perform is the so-called Christmas scan, which normally works on Unix systems. It basically uses, we can see here, unusual TCP flags in order to understand, in case we have a firewall if a certain port is closed or open, because now I'm going to show you how a system behind the firewall looks like. I had to use my physical system to perform an NS lookup on this domain because it doesn't look on Kali the way it's configured right now, and so Did I use? Okay, that's the information I wanted. That's the IP address of this website. This website is related to Nmap website, and it's a website that we have permission to test. It's a test system that you have formal permission to use for your tests, of course within certain limits, but anyway, we can perform a basic port scan on the system. Alright, if you go back to our virtual machine and we perform a stealth scan, I'm gonna keep going with that on a real world system. Wait, I think we have some connectivity problem. In fact, there's a weird issue sometimes with Kali Linux that it loses connection unexpectedly for some reason. And I found out that the most, straightforward way and probably the fastest way to correct this problem is to go here. Yeah, you see it's practically inactive. We only see the MAC address here. You want to drag the slider rightward and we're gonna have an internet connection back. Okay, that hopefully solved our problem. Okay, we have connectivity again. Sorry. Alright, so if we test a real world system, we're gonna have something different. We're not gonna have a bunch of open ports like we saw before. You see that we have a series of filter ports, and only a couple of ports are open, essentially SSH and 80 and this one. Now these are secure services. What does filter port means here? Well, I refer you back, like I said, to the official guide, and a filter port is a port we don't know if it's open or not because there's a packet filtering in place. So in other words, there's a firewall or an IDS or both that filters actively the port and prevents outbound traffic from reaching the port. So it might be open or not. That's what it looks like. Now there can be a way for you to understand better if such a port is open or closed. And it's called Christmas Scan. The way it works is activating a bunch of unusual TCP flags, because usually what you see used are the SYN, the ACK, and pretty much those are the two most important ones. Then these scans use other flags, and we'll see the way it works both from Nmap and from the wire. So I'm going to perform a Christmas scan against this target. Like I see, I've already stated that I can do it legally because this website allows us to do this. So I'm not gonna have troubles with this. Okay, so let's go ahead and perform a Christmas scan. We performed the scan and we didn't have any luck, and it says open filtered. It might be very likely that the firewall of the target system dropped the packets. So anyway, the way it works, you see from Wireshark that we have all these unusual flags activated. Now, why do we call it Christmas scan? Because all these bits are on as they are set to 1. Bits that have the value 1 are considered on bits. Bits having the value 0 are off bits. So we can always say that they're all lit up like a Christmas tree. In fact, we have thin, push, and urgent. Alright. We can perform a different type of scan when we have these open filter ports, which is here Tcp Connect Scan, because it determines if the ports are filtered or not. I refer you back to this website for more details, but anyway, we can perform it using SA here. Again, this damn caps lock. I'm going to perform a new capture on ATH0 because I'm connecting to the internet right now. So, another option I want to add here that's where you can have an overlook of all the options in the Nmap scan. You see there's a bunch of them. You can set timing template in order to speed up your scan. So that's what I'm going to do right now. So we're going to start a new capture here. And we're going to perform a scan on the system. You see it's much faster now, just because I added this timing templates. Now it says that all the ports are unfiltered, which means they're open. There's no firewall on that system. That's pretty much interesting. Okay. So that's what it looks like on the wire. I think that can be pretty much about it for today. I already overwhelmed you with a bunch of information, so I don't want to keep you too long. And in the next episode, we're going to deal with something like operating system fingerprinting and more advanced options. Until then, have a good one. Bye bye.